are streaming on YouTube. And
Got a recording.
Recording locally. And okay, we are set.
All right, okay, so ready to go. All right.
To the 2021 Virtual Christmas Summit, brought to you by Biscoyo Studios. This presentation is sponsored by CCL Controllers, some of the finest controllers out there. This is Jason Rasmussen giving his presentation on optimizing your audio, one of the most commonly overlooked items in a Christmas display. So Jason, it is all you.
All right, welcome everyone. This is optimizing your display's audio and transmitting over FM. And if you want to check out my lights, there it is right there. There's the URL, Lights on Symphony Street. So George Lucas said, the sound and music are 50% of the entertainment in a movie. And your display looks good, but does it sound good? Sound is very important in our display and is very often overlooked. Do you have poor audio, distortion, static, or flat, undynamic sound, or do you have audio issues? While audio quality is a lot more than just purchasing an FM transmitter. And the differences in visuals are very easy to see, but with audio, you really need to hear it to hear the difference yourself. And you don't have to spend a ton of money to have good audio. And audio questions always come up before the lights go on. So like you have your lights on and then, oh no, my audio sounds terrible. What do I do? So it's a good thing for those people in here. You're ahead of the curve. So way to go. So my name is Jason Rasmussen. I am from Anaheim, California. I have been doing synchronized light displays since 2017. I love theme parks. I live right next to one, in the shadow of one almost. You probably know which one that is. I love electronic music, hiking, and camping. And fun little facts, I have danced in Disneyland's Very Merry Christmas Parade from 1987 to 1989. Yes, that is me right there as Cubby the Bear in the Peter Pan unit. And if you so happen to look, you can find televised footage of me on the internet. So go ahead and look if you want. So those are some actual examples from audio and FM that I was doing. And I've seen a lot of displays where they can sound really bad. And if you've done this before, you've maybe heard your sound display like that. So you can have really good audio. Now, if you're just watching this recorded and your show is going, you're like, I need to find a quick fix and I don't have time to watch this video, then go ahead and do this. This is a quick and dirty optimize your levels. There's the link right there. Quick note, we're gonna have a lot of links in this, but you can pause it later and look at the links. So this quick little fix, it works no matter if you're using FPP, Xscheduler, Pi, PC, onboard audio, or the Sound Blaster. But I do recommend to please watch this entire presentation to get the most out of your audio. And this is the third year I've been presenting the audio, and I've seen and personally heard tons of audio show improvements. So I know this is absolutely helping people. Past one was one of the top viewed ones of the entire season. So yeah, people have been taking this to heart, and in the tons of displays that I've seen personally, like their audio is definitely improved. Here's an example. I just finished your X Essentials video on optimizing display audio, and I simply wanted to reach out to you and say thank you. I fought with numerous small audio issues over the past couple of years, noise, varying audio levels, etc. And your video helped me improve my audio quality by 1,000%. So yeah, you could too be jamming out to some good audio here. So quick intro and disclaimers. The Zoom presentation as well as YouTube will both add their own audio compression degrading the audio comparisons. So I'm mostly going to be using visual comparisons. Any audio examples are available for download if you want to check them out yourself. And this is not an in-depth audio discussion, but enough knowledge for you to make informed audio decisions, correct and avoid issues. And no royalties received from any product or any recommendations. I don't see a dime in any of this. So it's just recommendations for what works or what doesn't. So some audio terminology, decibels. Audio is measured in decibels, and decibels is a ratio. It's not a linear scale, and it compares the value of one number to another. We measure audio in negative numbers and work our way up to 0. And generally every 3 dB is doubling the volume. 0 is the loudest the audio can be without distortion, and any more than this, and you will clip the audio. Okay, dynamic range. This is the contrast between loud and soft. And songs will often use dynamic range to be very dramatic. And if levels are not set correctly, you can clip when you get to those higher parts in the audio. So audio cannot go past 0 dB or you will get distortion from the clipping. This cuts off the audio. And if you notice in there, the little red lines, any audio examples you see in here are from the program Audacity. I think tons of people use it. So there's your example. So you can see the red clipping. It means, hey, you've clipped this audio. The quieter parts in the song may not clip, but the louder parts can clip. And having audio, what is generally called in the red, is okay so long as it doesn't clip. And you can see on the right-hand side, there it is, where it's okay. It's technically in the red, but you're not clipping. As with this left side, it is clipping. All right, going to more on clipping. This distorts the audio and can never be corrected if files are saved this way. If the audio was clipped and saved in this manner, even reducing the volume will not recover the clip audio. So if you go into Audacity or any kind of audio program, you jack up the volume and you clip those parts, you resave it. Oh no, I clipped. Let me lower the levels. You've already cut it off, and you're not going to get that back. And clipping can also occur with bad audio and FM settings. So here is an example of clipping. So listen to your speakers. You're going to hear audio crack and crackle when it clips in the red. So watch this part up here and you can see visually when it clips, and you'll be able to hear that as well. So you can kind of hear some of the clipping in there. It just kind of gives that kind of nasty kind of distortion. All right, signal to noise ratio. This is the ratio between the signal, which is good, and the noise interferences, which is bad. And this is abbreviated SNR, and it's also measured in decibels. And for this, the higher, the better. Noise can come from many different places. It could be in the original audio recording. It could come from a poor quality sound card. It could come from bad settings. It could come from electrical interference. And we want the signal. We don't want the noise. And noise will only be amplified down the line. You know, like the phrase goes, garbage in, garbage out. Okay, normalizing. This is amplifying the entire audio file equally, so the loudest part hits 0 dB. And this will maximize the signal without altering the dynamic range. And even professionally recorded audio may not be normalized and can be too quiet when played with other songs you have. So for example, this is a song that I use in my display. It's The House by John Williams from Home Alone. And it's actually pretty quiet. It's generally a quiet song, but it wasn't normalized at all. So when I play this against my other songs that I have, it can be quite quiet if I didn't normalize it. And you can normalize Audacity, normalize with Audacity or a program called MP3 Gain. You will need to resave with Audacity, which will recompress the file, and you're going to lose some audio quality if you do that. But if you use MP3 Gain, this will normalize the audio without recompressing it, and that's going to be the preferred method. So compression. This is adjusting the dynamic range of the audio to a more unified volume. Now, this is not to be confused with audiophile compressing, which we'll talk more about in a little bit. And most radio stations will do this. This helps hide any inherent like hiss in the FM. It also kind of just gives it a good general unified volume. The dynamic range is altered. So softer parts are going to sound louder and louder parts are going to become softer. I personally don't like doing this as it alters the author's original intent and the quieter parts of the song kind of lose their impact. But if you're working with many files of various volumes, using dynamic compression will help unify all volume levels to a common value. And if you're running your show from a PC or a Mac, you can actually do this live. And I'll talk more about this later. All right, the equalizer. This is used primarily to compensate for inadequacies in the final output or to emphasize certain frequencies. I would recommend using it sparingly or not at all. And if you're broadcasting your FM to cars, I recommend just leaving it off or to flat. If you're using an external speaker setup where you can adjust the final IQ to your liking, go ahead and do that. But make sure you do that only after you optimized your levels, which we'll talk about in this as well. Okay, compressing audio. These are file types like MP3, AAC, M4A. These are what are called lossy audio formats. And MP3 is still an excellent format. Don't be afraid to use it. I've seen some people where it's like, oh, I don't want to use an MP3. I want to use the other. Don't worry about it. MP3 is a fantastic format. A properly encoded MP3 file will sound indistinguishable from the original, and Amazon compresses their MP3 music extremely well. So they are a fantastic source for getting your music from. Now, AAC files will achieve the same quality as MP3s do, but they do so at a slightly lower bit rate. And the bit rate, this is the amount of data that you give to an audio file. And higher bit rates are better, but there are points of diminishing returns. So for example, 128 kbps, that's the lowest rate that you're going to want for a decent sounding audio. 192, it's going to be very hard to tell the difference from the original. And at 320, that's going to be the maximum possible bit rate. Okay, so again, continuing with compressing audios. If you ever resave a file into a lossy format like MP3, AAC, whatever, if you resave it, you're going to permanently lose audio quality. And saving in a higher bit rate than the original or a different format, you're not going to improve your audio quality. So if you have a 128K, you try to save it at 320, you're actually going to lose quality. You're not going to improve it. If you do have to resave, a higher bit rate will cause less loss, but your files will be bigger. So a 128K saved at 320 will still sound like a 128K, but you're going to have slightly less loss. Here's an example in Audacity. When saving, I recommend the preset Extreme VBR, which is called variable bitrate with joint stereo. And your sound is basically going to be indistinguishable from the original. That's an excellent setting. Just a quick side note for some LOR users, they've had some experience where some problems playing back VBR files. So if you have that issue, just go ahead and save at CBR, constant bit rate. VBR and CBR, they're both part of the MP3 spec. And if you have a device that can't play back VBR, they're just not complying with the spec. It's not that it's a bad format or anything. Okay, DAC and audio quality. So DAC is the digital to audio converter. And this is the chip that converts the digital signals to the analog signals that we can hear. And not all DACs are created equal. A higher quality DAC will create better sound. So for example, on the right side there, you can see the black line. That's the digital signal that the file is playing back. But then the red line is going to be what the DAC is trying to recreate into a sound that we can hear. So with the audio quality, you want to have the strongest output levels without clipping. You want to reject noise instead of trying to remove it later. And it's better to prevent noise in the first place than to try and compensate for it later. And not all sound cards and FM transmitters are created equal. Okay, sound cards. So here's some of the most common sound cards you're going to see in this hobby. There's going to be the Raspberry Pi onboard audio, and it doesn't matter if you're running 2, 3, or 4. They're all using the same chipset for the audio. There's your insert generic name brand USB audio adapter here. I've seen people use the white ones. I've seen people use these black ones. There's tons of different types of these generic ones. There's also the onboard computer or laptop audio. And then there is the Sound Blaster Play 3, the external USB one, or you can even get various types of internal ones for your computer. Basic audio is poor audio. The Raspberry Pi and the inexpensive generic USB sound cards and the built-in audio sound cards are almost always going to use the same quality. Tons of different types of audio generic ones. Onboard audio and even quote unquote name brand ones nearly always use the generic chips. And while they may output sound, they don't output quality sound. You're going to have lower output levels. Generic poor quality off-the-shelf DACs, which kind of sound flat in many cases. You're going to have poor signal to noise ratio. There's going to be a loss of fidelity, range, fullness, and clarity. And in some cases, it can actually be worse than the onboard motherboard audio. And it is easy and inexpensive to upgrade your sound card. So this is the one I recommend, the Sound Blaster. Creative Labs, if you're not aware of who they are, they've been making high-end PC audio since the 80s, investing heavily into audio research, and it is the #1 brand for superior audio in computer sound cards. The Sound Blaster Play 3 USB, it's going to be the least expensive and the easiest way to vastly improve your audio, whether you're using your PC, Mac, Raspberry Pi, BeagleBone, from there. Now, there are better Sound Blasters, some that cost even hundreds of dollars if you wanted to go even further. But for Christmas light audio, this is going to be your perfect fit. You also have additional functionality if you're running like Xscheduler from a PC or Mac. You can use an equalizer. And again, I recommend using it sparingly or not at all. You also have a compressor, on-the-fly compressor. This is what they call a smart volume in here. And this will automatically adjust loudness for sudden volume changes. And like I said, I don't necessarily recommend it, but some may like this. And it is a one-click fix to fix the volume in all your songs. I mean, I've helped so many people with this. It's like, oh, my audio levels are so bad, but I'm using the Sound Blaster. Click it on. Oh, wow, everything just sounds nice and unified. It's wonderful. Okay. You will have improved audio over generic onboard or USB audio. You're going to have high-end custom proprietary DACs, digital audio converters. You're going to have superior sound quality output and high signal-to-noise ratios. It's going to be isolated from other components and help reduce interference. And speaking of interference, Shane, if you can mute some people on here. Again, I'm getting some interference and some kids in the background. I don't know who it is. So make sure everyone's audio is muted. Speaking of signal to noise, we've got a lot of noise here. And you can extend your sound card location away from interfering electronics with a USB extension cable. That's another advantage of this. And in some cases, USB audio is going to be your only choice, such as when you're using a laptop, a Pi Hat, or a Pi Zero. When you put one of those Pi Hats on there, it disables the onboard audio. And so your only choice is USB audio. And here are some real world users. So this is Lee Lindquist. I switched to the USB Sound Blaster this last year, and the difference was night and day. The difference was immediately noticeable to myself and lots of my viewers. I've been running FPP for 4 years now and can't believe I waited that long. Why didn't I do this years earlier? That's David Peace from the Peace Family Light Show. And the entire Lights Alive, the 1 mile drive-through display, which that one ran on a 0.5 watt SignStack external J-pole antenna, Sound Blaster Play 3, and the audio reached all the cars, perfectly synced with superb audio quality. And that's Matt Johnson of Living Light Shows. Okay, so here are some visual comparisons of the audio, and this is the generics versus the Sound Blaster. So on the left-hand side, there's a lot of different things that can happen when you're using just cheap chips. So here's a generic sound card at 100%, and it's not having the full audio range. You're going to have drastically reduced audio output. In some cases, you could have clipping. So you put it at 100% and you got clipping. One notch down, it's not clipping, but you're going to get reduced volume. In some cases, playing back a silent audio file, you're going to get sound. So here's a generic sound card with noise. If you're playing a silent audio file, you should have silence. Here's a Raspberry Pi. This is at 100%. So not only does it have drastically reduced audio, it actually has distortion in the audio file itself. Now, on the right-hand side here, this is a Sound Blaster Play 3 playing a silent audio file. We have silence, as it should be. Also, you're going to have very strong audio levels. So this is maximized right here. There's no audio clipping. So really, really good levels there. So with the tests, audio needs to be heard to be believed, but let's see it, because you're really not going to hear the differences over Zoom here specifically. So these are the visual comparisons of the audio versus the sound card output. And at home, if you're using a generic sound card to listen or using poor speakers, the comparison examples may not sound too different. And there's my test files if you want to check them out yourself. So this is the Raspberry Pi, 2, 3, 4, doesn't matter. You're going to see right here, this is the top. The top one is the original audio file. And then the bottom, this is the output that I'm getting from it. So we have a huge reduction in output levels, and that's at 100%. And it sounded distant and muffled, and there's a loss of treble and clarity, and it just kind of lacks presence. So here's your average generic sound card, and other name brand sound cards, or even, whatever onboard ones, they're going to have similar results. So I can't compare every single one, but there's a huge reduction in audio levels, even at 100%. And there's a loss of fidelity and sound detail, and it just really lacks presence. And in some cases, these actually sound worse than the Raspberry Pi. Here's your Sound Blaster. There is no reduction in the output levels. And this sounds identical to the original. Even visually, you can see it looks exactly like the original. And the Sound Blaster is by far and away going to be the clear winner in audio quality and signal strength. And at $19, it's a no-brainer light show upgrade. So how do you install this thing? All right, if you're on a PC or a Mac, go ahead and plug it in, install the software from Creative's website. And in the settings, make sure SBX Pro Studio is off. Smart volume, that's optional, up to you. And then I recommend leaving the EQ at flat. And then make sure you set the gain to normal and the volume at 100%. And then plug the audio into the Sound Blaster, and you're good to go. Now, for a Raspberry Pi or BeagleBone, make sure you're always using the latest version of FPP. Go ahead and turn off your Pi, plug it in, turn on your Pi. And then in the settings, make sure you select Sound Blaster as the output in the FPP interface. So make sure you select that. I've had people plug it in and they don't change the interface. So make sure you change the interface. And then go ahead and restart FPPD. And then set the volume at 70%. This should be the default, but just go ahead and double check it. Make sure it's set to 70% or you're going to clip. And then plug the audio into the Sound Blaster and you should be good to go. Now, we haven't optimized our levels yet. We just set it up. We'll talk about optimizing audio levels a bit later. So FM transmitters. A quality FM transmitter cannot compensate for a bad sound card or bad levels. So I recommend you find an available frequency. There's a good website where you can find it'll just give it kind of like a general idea of what the best frequencies in your area are. And what's listed may not be the best. So make sure you test yourself. So in my case, this is the search result that I got, but I found that 89.1 was the best frequency for me. Quick note on, we've got some feedback from some people. Some people said that some cars, for whatever reason, are having trouble picking up the lower FM frequencies, such as 87.5 or 87.7. So kind of as a recommendation to help avoid this, use the range 88.1 to 108 FM. So it's just kind of a weird instances that some cars just don't pick up a level that's within the FM spec. So yeah, go ahead and do that. Also, only transmit as far as you need. You don't want to interfere with other stations or to raise the eye of the FCC. And even a half-watt transmitter in low power can transmit for blocks or even miles. Okay, so here are some of the most common FM transmitters in our hobby that I've seen. This is just kind of a quick comparison chart that we have here. I'll go into kind of detail on each one and kind of tell you the pros and cons of each one. So, and all these tests were done with the same antenna and locations to make sure everything was fairness in testing. So you can look this over, pause it later, but I'm going to go into little depth into each one. So as far as the ones that I recommend, here are just the blind listening tests, listening from the audio from these. The SignStech, this is going to have a strong signal, but there was just a slight hum in the quieter parts. There was a little reduction in the treble, but overall it had very good sound. This $5 transmitter that you can find on eBay, generally $5 to $10, but I just call it the $5 transmitter. There is a slight buzzing hiss throughout. There is decent fidelity, though slightly muffled. The audio is a little bright, but overall, okay, it's a good little card. The EDM, it does have a strong signal if you set it to 100 milliwatts. So make sure you go in there and set it to 100 milliwatts. I'll show you that in a little bit. There was a quiet buzz throughout. It did sound more muffled and actually kind of overall just kind of sounded average. The $5 FM transmitter, it had more buzz than the EDM, but it also had more treble than the EDM. The EDM had slightly less buzz than the FM transmitter, but it also sounded more muffled. Now, out of the box and for the price, the SignStech half watt sounds the best overall, and it's the only one with an included antenna that actually worked well. All the FM transmitters here listed, they all will benefit from a dipole antenna and a Sound Blaster Play 3. And we'll talk about the antenna in a little bit. So pros and cons of each one. So the SignStech half watt, this is 500 milliwatts at high power and 100 milliwatts in low power. Here are the pros. It's going to have great sound and range. It comes with everything you need, including the audio cable. And the included antenna actually works pretty well. For the price, it's going to be your best FM transmitter. Now, recently with the whole staying at home and all this other fun stuff, the prices have increased in these pretty dramatically from like 60 to 130 bucks. The lowest I ever got one of these was 30 bucks. The con on these, there is no RDS data. That's radio data system. Basically, it'll like if you have it connected to your PC or Pi, it will tell you like what title the song is. So this doesn't do RDS. Not a game changer necessarily. Also, the analog dial set to input, it's not digital, so you could accidentally bump it and change your levels too high or too low. And on very rare occasions, I've had it not turn on. Very, very rare, but it's always come back for me. But no matter what FM transmitter you get, always make sure you have a backup. So always have a backup. For the power adjustment, so these will come default in high power. I recommend setting to low power. I also recommend only buying the half watt one. This is how you do the power adjustment, since some people have had problems with figuring it out in the manual. You press and hold the power button as you plug the AC power in. The LCD display will show L for low power, high for high power. Recommend you set it to low. And you can toggle between the high and low with up and down, and then you push power to set. So here's a quick little video of setting the power in this. There's your AC adapter. Hold down power, plug it in, let go of power, up for high, down for low, push power to set, and you're good to go. The $5 FM transmitter. Here are the pros. Good sound and range. Surprisingly good little guy here. It's great to have as a spare FM transmitter. It's also great for compact or battery powered displays. Plus, you can digitally set the input. I recommend setting it to 26 and you'll be set. So cons of the FM of this one, you do need to solder your own antenna. So you're gonna have to bust out that soldering iron to plug in the antenna. And you must provide your own audio cable, USB power, and power cable, and optional housing if you want to. It's just a spare little board. And while it is a good FM transmitter, the USB sound card is poor. So only use it as a line in. Do not use it as a USB audio device. So it does have a USB connector. Only connect that for power. Don't connect that for USB audio. The EDM. So the pros on this one, it does have good sound. you can also get models with RDS. So you can broadcast that information and tell them kind of what song title it is on the display's radio, if a radio receiver supports that. It does have recessed gain controls, so it's difficult to accidentally bump. So once you have it set, which is not that fun to do, you're not going to accidentally bump it. So the cons on this one, it is pricey. They're around $300. And it does require a little bit of minor assembly. And the left and right volume controls, they're separate. So it can be difficult to properly tune the input gain on these. Also, the included antenna is very poor. And it is very expensive when FM transmitters at a fraction of the price sound and perform better. Inside these, you can adjust the power adjustment. By default, I think they come at 10 milliwatts, but you can just open up the case, flip a little switch, and you can go to 100 milliwatts. And I had this little picture on how to do that. Here's another one that has been used. I've been playing with this for a little while. This is the SI4713 FM transmitter chip with RDS. I was really looking for like a good, inexpensive FM transmitter that had RDS, and I've been playing with this. For the Pro, it is the cheapest way to get FM with RDS. But for the cons, I'm sorry, it has poor range, even when connected to an external dipole antenna. And it actually has pretty poor sound quality. It does have problematic and poor audio quality gain and compression. And it just kind of fluctuates the audio all over the place. I can hear the difference, and it doesn't really sound that great. Also, it's very low powered. I mean, this will only do 22.8 milliwatts max. And these are all specs from the actual chipset manual. And even in the manual, talking about poor audio quality and range, you can see it says right here, remember, the range of these low-powered FM transmitters is limited, and you might need a radio in the very same room or close by to pick up the signal. And it can only transmit audio up to about 10 meters or 30 feet away. That's been my experience. That's been the experience of other people who have tested this as well. It does require minor assembly and a software plugin to work. And while it is the cheapest way to get RDS, and it is functional, in my testing and others' experiences, I'd rather have better audio quality than RDS. Your best bet, if you want to get FM with RDS, is to use the EDM transmitter, but those are going to be a bit pricier, around $300. So the stock antennas here. The only stock antenna that is good is the SignStec. The EDM stock antenna is junk. The other ones don't come with an antenna. And while a dangled wire from your FM antenna works, you're seriously limiting yourself. All FM transmitters can benefit from a dipole antenna. And with any antenna or FM transmitter, your results may vary due to numerous factors such as local FM interference, terrain, objects, etc. So, dipole antenna. You're not limited to only stock antennas or a cheap dangling wire. Dipole antennas will essentially eliminate the buzz and hum from stock antennas. It's also going to increase your range and reduce any static drops. While it does not improve the audio fidelity, make sure you use a sound blaster for this. You can mount these in more locations, such as inside the house, outside, the roof, the chimney. But mounting antenna, higher the better. And the DIY Christmas forum has an easy build. And also in the VCS 2021, they're going to have a build party of one of these. So if you want to build one, go ahead and jump in. There's the PDF if you want to check out the link. And for best results, it must be cut to the frequency you choose to broadcast on. So pick your frequency ahead of time before you build it. And you're going to want to mount it vertically in the correct orientation, and the higher the better. And there are many other types of antennas, such as a J-pole and such, but this dipole was very easy to build and it had outstanding results. Feel free to use antenna adapters or RG6 extension cables. So if you need to, extend it out further, go ahead. You can do that. You can use adapters. So as long as it's a solid fit, it's really not going to affect the antenna transmission. And there's some adapters you can use for the SignStec or the EDM right there. And on the back screen, that's the dipole antenna that's actually in my garage. I only have a single story, but right there inside my garage, behind the garage door, works fantastic. So here's some test results. This is with the stock antenna of the EDM and the $5 FM transmitter with a wire. So you can kind of see right there, everything in the green, that's where it sounded good. Yellow, you got some static. And then in the red, you just got nothing but static. So that's those transmitters, EDM $5 transmitter with stock antenna and a wire. And range was the same on those, but just changing out the antenna. Actually, before we do that, this is the stock antenna for the SignStech. So the SignStech, it had a much better signal strength. Again, these are all operating on the same power transmission. So a much better antenna here. So out of the box, you're good to go with that one. Now, plugging this in to the dipole antenna, they all benefited. They all had the nice same range and clarity with this one. So you can see much better range, better clarity, less static drops. That's going to be a big improvement to your display right there. So quick note on transmitters with the high power and the mounting. High powered transmitters greater than 5 watts. Here are some precautions. Do not recommend you get them. All of these have occurred with transmitters higher than half a watt. You can get distorted audio. You can get bleeding into neighboring stations. You can knock out USB sound cards. There's also can be interference with other electronic devices, such as garage door openers. There have been reports of Christmas lights and controllers acting erratically, flickering, or not even turning on. And you may be violating transmission limits. So avoid using FM transmitters higher than half a watt. Even with these higher ones, even in low power, they can transmit at 1 watt or 5 watts or even higher. And that's 10 to 50 times greater than the recommended amount. So for the antenna mounting location, you want that to be closer to the audience, if possible, with the least amount of obstructions. And you want it at least at head level or higher and not on the ground or in the basement. And you want the antenna with just like the stock antenna of the SignStech, you can have that pointing up or down. But if you're using the dipole antenna, it must be vertical with the top element pointing up. And that's going to be the center core wire when you're connecting it. So optimizing the audio levels. So we've got the sound card, we've got the FM transmitter. Now we need to make sure that our levels are optimized. And non-optimized audio levels can result in distortion and noise. You can have a loss of audio levels. You could have future problems down the line. The best way to optimize your levels is using a test tone. So you can generate this in Audacity, or you can download the link for yourself over here. This is 100 hertz test tone set at 0 dB. This is the maximum audio output level you can have without distorting. And if you hear any distortion at any other point in your test, then that device is clipping. So like I said, you can use this 30-second sample that I created. You can download it yourself, or just go into Audacity and create 100 hertz frequency tone at 0 dB. And that way you have a nice clean sound wave that you can use for testing. So let's prep it. So first thing we need to do is prep the sound card. If you're using FPP, make sure you select the Sound Blaster as the output and restart FPPD. Set the volume to 70%. That's the default. So you should be at 70%, but just double check. If you're using a PC or a Mac, turn SBX Pro Studio off, turn Smart Volume off, set your EQ to flat. After you do your optimization, you can turn on Smart Volume if you want, but like I said, only after you optimize the volume. Make sure you have it set to normal gain, volume 100%. If you want to be safe, you can set it to 95. So if you're using a generic audio card, so you're watching this presentation later, you don't have time to get a Sound Blast or anything else. You have just your generic audio. It's like, I got to optimize my levels. Well, you can still optimize your levels. Set the pi to 100%. If you're using generic onboard audio, like on your computer, set it to 100%. You can do it a little bit lower if you need to. And if at any point in testing you still get clipping, go back and lower your output levels by 5. All right, so let's prep that FM transmitter. So go ahead and turn the input gain on your transmitter to 0, all the way down to 0. And you can see I highlighted right here, this is where you set your gains. If you're using the $5 FM transmitter, you can just set that to gain to 26 and be done. Since it's digital and it should be uniform between all of them, just go ahead and set it to 26, and then you're set with the gain on those. For all the other ones, turn it all the way to 0. And then make sure you prep your car radio or your loudspeakers. Turn the final volume around 10 to 20%. You don't want them too loud because you don't want those to distort yet, because we're trying to find where the maximum level is in the gain on our FM transmitter. So your final output, whether it be your car or just little speaker, your FM radio you're testing with, go ahead and turn the volume level down on those. And if possible, turn off any EQ, bass, or treble enhancements if possible. Okay, so let's optimize this. So go ahead and play back that 100 hertz test tone. So, you generated it in Audacity, or you downloaded it, loaded it into FPP, loaded into your X scheduler to play back the audio file, and go ahead and put it like to a loop so you can kind of keep testing your levels. So what we're going to want to do when you're playing back that test tone, you're going to slowly turn up the gain or volume on your FM transmitter. If you're using loudspeakers, then you can adjust your loudspeakers. But as far as the FM transmitter, which most people are using, you're going to want to turn the gain up on those. So you can see there's the gain controls down there in the lower right. Once you hear clipping, you're going to want to slowly turn down the gain until you no longer hear clipping. So I'm going to play back an audio example so you can listen and hear it. And you can visually see what's happening when you're optimizing your level. So again, I'm just playing it back for visual comparison on Audacity, but this is a real world example of me playing back a test tone from FPP, and then I am adjusting the volume on the gain control in my FM transmitter until I get distortion, and you'll see and hear when you get distortion, and then I'm backing it down until there's no more distortion. So go ahead and take a look and listen. So there's distortion. It's too high. I'm going to back it down. You can even see the audio file distorting. So that's pretty good there. I've turned it up too loud. All right. That looks and sounds, too much. There we go. That looks and sounds good. So that's what you're going to want to hear. Now your input level is optimized. So go ahead and leave those gains on your FM transmitters. Notice you're going to have a strong, clean audio signal. And if you still hear distortion, go ahead and turn down that sound card, those levels that we showed previously, and go ahead and try optimizing again. Now you can turn your final output up. So go ahead and turn your output higher in your car speakers or loudspeakers, whatever you have, and you're going to have a good quality sound. Your audio should sound strong without clipping. And if you hear clipping at higher level, any clipping heard at higher levels now are not due to the sound card or FM transmitter. So like if someone else has their, booming sound system and they just optimize their levels wrong and they're getting clipping, the problem's on them, not you, but you want to make sure that you're not broadcasting clipping. Okay. Audio cables. The stock audio cables can often be poor. And a good audio cable will never fix incorrect set gain, a poor sound card, or poor audio files. I've seen it too many times where people online have audio problems and people are, just get a better audio cable, get a better audio cable. And it's never going to fix those other problems at all. Now, monster cables are good. They just cost more, but there are others that sound just as good or that are just as good. And here's some good affordable brands: Monoprice, Cable Matters, Amazon Basics. Make sure you buy ones that are shielded with gold connectors whenever you can. It should say shielded to prevent EMI or RFI interference. And here's some example. There's a $2 one from Monoprice and Amazon Basics. Those are good ones. And if you need to split audio into two outputs, like to go to FM transmitter and to also go to external speaker, just go ahead and use the stereo splitter. All right, Bluetooth speakers. You get this all the time. Just don't. There's going to be too much latency that you can never overcome with Bluetooth. And all Bluetooth audio is going to be recompressed. Some Bluetooth speakers do have an auxiliary input or an FM tuner built in. If so, connect your audio to the aux input or use the FM tuner because you're going to get no latency in the audio. Also, Bluetooth or wireless headphones, never sequence with Bluetooth headphones. Repeat it with me. Always use a hard wire. Okay. Never sequence with Bluetooth headphones. All Bluetooth has latency. Even the low latency has latency. Your sequences will be out of sync. Outdoor speakers. We've had a lot more people use outdoor speakers. I use outdoor speakers. If you're connecting it to an amp, make sure, okay, the Sound Blaster can only power headphones at most. It's not going to power big speakers. I've had people plug in big speakers and they wonder why it doesn't work. So you're going to want to make sure you connect it to an amp downline. Recommendations, I recommend Polk or Klipsch for outdoor speakers. Those are going to sound wonderful. If you're on a budget, the Dual Electronics outdoor speakers are pretty decent. And for amps, you can use a dedicated amp. You can even use a car stereo amp. That's what I have. I just use a car stereo. It's more than powerful enough. You can use the FM or the auxiliary into those. You can even use a home theater receiver, and you can find these super cheap at thrift stores. So if you need an amplifier, just go to your thrift store, pick up a home theater receiver, and you'll be fine. Now, car audio delays. There are some systems that have audio processing delays, and it's going to be out of sync. And if this is the case, there's nothing that you can do on your end to compensate for this, nor should you try. The best you can do is try having them turn off audio enhancements in the car, but there's nothing on your end you're going to be able to do to fix that. So external mixers. Yep, thank you. So external mixers, in general, these are unnecessary. If you're using an external mixer in an attempt to correct poor audio source, it's generally a bad idea. Again, garbage in, garbage out. Always start with a quality sound output first and upgrade your sound card. That's going to be better. The Sound Blaster Play 3 is going to be way less expensive than an external mixer, and you will have better results. Some small mixers have USB audio like this one, and while it's probably superior to the onboard Pi, it's likely going to be inferior to your Sound Blaster. If you're using a PC or Mac, the Sound Blaster control panel has all the controls and the software you should need. Okay, some Ferrite cores. I'm going to go a little bit faster through these since we're running out of time. These are going to help reject EMI and RFI interference. You're going to want to wrap around the cable at least once when possible, and you can place these on the AC or audio line and place the cables closest to the noise source. And while it may not perform miracles, they do help. So let's do some troubleshooting. While I can't anticipate every possible audio problem, here are the most common ones I've seen. So for the testing method, always start your testing at the source and move down the line. Is the issue present in the audio file? Is your issue present at the sound output? Plug in the headphones to your sound output. Check it from there. If the issue is the issue present in your FM transmitter? Test with different FM receivers, though a car radio in the viewing area is the best bet. So clipping or distortion. Clipping can occur at the audio file, at the sound card, at the FM transmitter. It could even occur in the final output, such as car stereo or speakers. So make sure you start with the source, including the audio file, and move down the line. When in doubt, turn the outputs down a level. Go ahead and reduce like in increments of 5. Are you plugged into the auxiliary and not the mic? Go ahead and start over and re-optimize your audio levels. What about static? Starting with the source, again, including the audio file, do you have an poor antenna? Maybe try a different antenna. Check for cable damage. Check your connections. Check the antenna ground. Make sure that's connected. Maybe mount the antenna higher if you can. Try a different antenna. You could also try the output level. Maybe try a higher output level. Like if you're using the EDM at 10 milliwatts, bump it up to 100 milliwatts. Maybe you have electrical interference. Try turning off other nearby electrical devices and cables and see if that helps. You can also use a USB extension to move the sound card and FM transmitter away from other electronics. Try different radio receivers. Not all receivers are the same. Some radio receivers sound great, some don't. So try different ones. Warbling, this can sound like an ocean wave sounding. If you're using lower bitrate audio files like YouTube rips or files that have been recompressed multiple times, this is severely going to degrade the audio. There is no way to recover from low bitrate or recompressed audio. The damage is already done. Recompressing audio will degrade it further. So make sure you seek out higher quality audio files. Go ahead and spend that buck, buy the MP3 from Amazon. Also, it could have possible interference. Try a different FM channel. Ground loop. This is a constant like low hum that you hear in the audio file. This is caused generally by being connected to 2 different paths to ground. There's some resources that'll tell you more about a ground loop. Go ahead and try moving things around so they plug into a common AC outlet. You can use an electrical tester, make sure the outlet shows correct. You might have a bad outlet. You could also try a ground loop isolator. So it may eliminate your ground loop, but it might reduce your audio quality a little bit. Interference, try a different FM frequency, try a different antenna location, or even a different antenna. Try a different FM receiver. Some, like I was mentioned, some tune better than others. Try separating the FM transmitter and audio device from other electronics, like use the USB extension cable. Also, metal, brick, glass, that can cause interference. Go ahead and turn off other devices. I've had some person had like a refrigerator that was causing audio interference. The ferrite cores, those can help reject interference. Maybe you have a ground loop. Also, some USB hub NIC cards that can cause audio interference. So use a USB 2.0 100 megabits one instead of the USB 3 gigabit hub. We've seen people have problems with these. So go ahead and use the other one. There's a link to one. Power. Okay, this is an important one. I'm going to spend a little bit more time on this one. More power. Inadequate Raspberry Pi power. I have seen this so much. The Pi requires adequate power to operate properly, 2.4 amps for a Pi 3 and 3 amps for a Pi 4. Adding more USB devices is always going to draw more power, even if the Pi appears to be okay. So power problems, you could have random reboots, USB devices like the Sound Blaster disconnecting or not even showing up. Don't reuse your old AC USB adapters or USB power cables you have just lying around. I have seen a ton of bad USB cable and underpowered Pis in 2020. That was like my biggest troubleshooting problem that I had with people. So make sure you get quality ones. When in doubt, replace the USB power and USB cable with newer quality ones. I recommend USB power cables like from the official Raspberry Pi Foundation, CanaKit, Aki, or Anchor. And there's some links on one that you can check yourself. Also, FM power, too much power. So not enough power and then too much power. An FM transmitter higher than half a watt will cause interference or knock out USB devices, or will cause them to not even show up. Yes, even your 5 watt, 7 watt and higher can be cheaper, but don't be tempted to get them. I do not recommend using FM transmitter over half a watt, as all sorts of weird issues can occur. And separating the FM transmitter, I've seen people say that's, you separate it. Yes, you can separate it from the other devices, which may help, but you're still overpowered. You still have that problem. All right, extra tips and tricks with the control panel. If you're using a PC or a Mac, you can use the smart volume, which is your dynamic audio compressor. This will raise and lower the audio to a more even level on the fly. And there's no need to optimize any audio, no need to normalize any audio file. It will affect your dynamic range. And some actually may prefer how this sounds. And it can help hide any noise inherent in the FM transmission. So that's a one-click fix to basically set the volume level for all your files. So here's some hardware availability and alternatives. So this SignStack, it's been harder to come by recently on Amazon, and the prices have increased. And sometimes they're even out of stock. And yes, you can find the 7 to 15 watts. They're easier to find, but again, not recommended. Watch out for Amazon Lightning deals. Like I got my second SignStack for $30. Here's some alternative sources direct from SignStack. You can find them on eBay, new and used. You're probably going to find a lot more used now from churches reselling theirs. You can also find knockoff brands, though I haven't really tested them myself specifically. Also, some people have had good luck with the whole house transmitter. I haven't had a chance to test it myself, but some people say they have good luck. For the Sound Blaster Play 3, that's only $19, but if it's out of stock, which has been affectionately called the Rasmussen effect, you can buy it direct from the Creative Store. Also, you can find the Sound Blaster XG1, which is a slightly improved version for $29. It's specifically for gamers, but it's basically going to be identical. And yeah, that frequently bought together, that's actually from Amazon. So yes, that is the Rasmussen effect. It definitely happens, and it sells out on Amazon. So to recap, audio output. You're going to want to use quality audio files from reputable sources like Amazon. Avoid your YouTube rips. You're going to want to use quality USB cables. You're going to want to avoid recompressing with possible and use a higher bit rate to resave. Normalize your audio files. Make sure you use MP3 gain. Optionally, use the smart volume in the Sound Blaster software. Use a quality sound card and avoid generic built-in audio. Avoid any audio enhancements. Set the EQ to flat. Only EQ if you have control over the final output. And for the FM transmitter, always use the auxiliary or line in. Mount the antenna at head level or higher, or use a better antenna. Use the ferrite cores on AC and a quality shielded audio cable. Choose a free FM frequency. Only transmit as far as you need. Use that half watt one or lower. Test for sound issues starting at the source and go ahead and move down the line. and make sure you optimize those levels. Use the test tone, turn down the stereo and the FM transmitter to low, and then turn up, playing back that test tone, turn up the gain until it distorts, and then go ahead and back off. And then from there, you can, actually, that's what I just said right there. So back off after it sounds good. And so you can go back and look at that. We're going to wrap up really quick here. Here's a nice diagram that Shane made. It shows you how you connect all your devices together. So you can pause this and go ahead and look at that and see, oh, where do I connect everything? So, and go ahead and ping Shane if you have a question on his connections. He did a really good job on this. So here are the recommended products. You can pause this, take a screenshot, and you can see all the different recommended products that we have here. And then I got some special thanks for some people who have been helping me with all this. So I think we are at the question point, and we have just a couple minutes left. Yeah, I just kind of ran up right to the end.
Hey, Jason, I got a real quick question for you.
Yes.
When we're using MP3 gain, I find that my audio files are still not the same sound level. So what would you do to try and fix that?
So
And
normalizing.
this is running from FPP and a Pi, so not using a PC for smart volume.
I would probably have to see the actual audio files and what they are, but remember MP3 gain, it's not going to compare two different audio files and make them the same level. It's going to take the highest part of that one individual audio file and make that 0 dB. So just the highest level is going to be 0 dB. So if you have like a really quiet song and a really loud song, the loud song is really not going to be changed, if at all, but then the quiet song may go up, but it's still not may be loud enough. In that case, you're going to want to take like your quieter song and maybe do dynamic compression on that one, or you can use like the smart volume if you're running it from a PC or Mac, and then that's going to optimize the levels overall at different audio files.
And where is that dynamic compression at? Is that in Audacity?
So yeah, in Audacity, there is, I'd have to find it. You can hit me up later and I can show you that, but yeah, you can do a dynamic compression on that, which will raise the volume of the lower parts and kind of reduce the volume of the higher parts and make it kind of a more unified sound. But again, you are changing the original audio file from there.
So I guess for a generic response, what's the best way to get all of your audio to be relatively the same decibels?
Relatively the same is to run them all through MP3 gain.
All right, thank you.
Mm-hmm.
Yeah, actually, I have a question. Have you noticed much variation between how different car stereos pick up FM audio? Like I have, or I have an old pickup truck, probably with a stereo from the early 2000s, like some aftermarket Kenwood, and we have our 2012 Dodge Journey with the just like a stock stereo, and the stock stereo sounds great and stuff. But there are a few songs that I have that there's certain parts I wouldn't say it's like normal distortion. It's almost like it's some sort of like digital scrambling happening, for lack of a better term. Have you noticed that like newer car stereos tend to process audio more, and sometimes you run into problems with certain MP3 files? Because I have other songs that have louder portions of the song with no distortion at all.
So on a lot of newer car stereos, there's like two things going. FM hasn't been the most important thing for everyone on those. So usually they'll have like audio processing, post-processing that doesn't always sound good. Also, different receivers some receivers are going to be great. Some receivers are going to be bad. Plus on newer car audios, they're usually not having a full FM antenna. They're using like the little shark fin antenna or like an antenna built into the window, which better than nothing, but it's not going to be good as some of these other ones. So yeah, go ahead and check with test different receivers, because you're going to get a varying range on different receivers.
Yeah, well, unfortunately, I'm not going to be a unit or stereo. I was just kind of wondering if you've run into that problem.
I have.
Yeah, Journey has a little shark fin antenna in the back, so or a little bit bigger than a shark fin, like 6-inch or something.
All right, I think that's it for me. So if you have any other questions, just go ahead and post it and hopefully we'll try to help you. So I hope that helps with everyone's audio.
Yeah, thank you.